Good to see you. Mr. Sutton here with the AB Calculus 4-6 Extra Practice Number 3 solutions on graphical analysis. For this problem, we're given the graph of f prime right here, and we're asked which of the following statements about the graph of f is true at x equals -2. So keep in mind, they're asking about f, but we have the graph of f prime. So let's go through and see which one of these we can eliminate. So first statement, f is not continuous at x equals 2. Well, we can see here at x equals 2, -2, that the graph of f prime exists, the derivative exists there. Therefore, the function, if it's differentiable at -2, must be continuous at -2. So this is a no. Moving on, f has an absolute max at x equals -2. Well, we see here that f prime is positive from, at the very least, -5 to 0. So that means that the graph of f itself is increasing until we get to x equals 0. Well, if f is increasing between -2 and 0, then -2 can't be the location of the absolute max. So this is also a no. Next, derivative of f does not exist at x equals -2. Well, it does. It's a solid line right here on the graph of f prime. So that means that that's a no as well. That's also false. Next statement, graph of f has a point of inflection at x equals -2. Well, the graph of f prime is going from increasing to decreasing. It's reversing direction. So that does tell us that we have a point of inflection. So if f prime is changing direction, increasing to decreasing, then this is a yes. So choice D, it's looking like, is a pretty good one. Let's just look at choice E, just to be fair about it, though. Graph of f has a vertical tangent line at x equals -2. Well, if f had a vertical tangent line, then the derivative would not exist at x equals -2. Since f prime of -2 does exist, this statement is also false, so choice D it is. On this problem, we're given the graph of f prime, and we are asked on what intervals f is increasing. So f is going to be increasing wherever f prime is positive. We see here that f prime is positive between -1 and +3. And we have this little spot here at x equals 2 where it becomes 0, where it's neither negative nor positive. But if the original function exists, which it must because we're differentiable here, then you're allowed to include that on your interval as long as it's only one spot. So since we are greater than or equal to 0 on -1 to 3, that tells us that f itself is increasing on the interval from -1 to 3. So that's going to be answer choice B. For this problem, we're given the graph here of f double prime, and we want to know which of these graphs could be the graph of the original function f. So we're going to take a look at the sign of f double prime on here. We start off with a positive value of f double prime, then it dips below the x-axis to become negative, and then we have a positive f double prime again. So in terms of the original function, that means that initially our function is going to be concave up, then concave down, then concave up again. So we have to start concave up. So already that's going to eliminate choices A and C. So it's choosing between B and C. Okay, so after concave up, it's got to be concave down, and they both meet that condition. But then we need this third interval where you're concave up again. So choice B doesn't have that third section of concavity. It's concave up, then down, then, well, nothing. Choice D, on the other hand, we're concave up, down, and then up again. So choice D is the best one here. On this problem, we're given f of x, and we want to know on which of the three intervals given in the graph is our first derivative positive and our second derivative negative. All right, so let's analyze what each of those things means. If the first derivative is positive, that means that f is increasing on that interval. And if our second derivative is negative, then f is going to be concave down. So we're looking for an interval that has both of these properties. Just taking a look at each of these, because it could be more than one of these answers. The interval from A to B right here is increasing, but it's concave up, not down. So that's not what we're looking for. Next interval, B to C, that is also increasing, but it is concave down. So that is exactly what we're looking for. So anything that does not have option 2 in it needs to be eliminated. Now option 3, C to D, on that interval we're actually decreasing, so that already is not what we're looking for. So then only option 2 meets the conditions they set forth. So that would be choice B. For this problem, they're telling us that y is a function whose first derivative is positive and second derivative is negative for all x, and they want us to find the graph of f based off of that. So just looking at each of these, if y prime is positive, that means that our function, our original function, must be increasing. And if y double prime is negative, that means our original function is concave down. So looking at our options here, A is increasing, but it's concave up. B is increasing and concave down for the whole interval. So far B is looking like a good answer, but let's look at the others just in case. C is decreasing, so that's already not going to work. D is decreasing for part of it, so also no good. And E is concave up for part of it, so that also doesn't work. So then choice B is the only one that meets both of these conditions. For this problem, we're given the graph of f prime, and we want to know which of these statements has to be true. So looking at them one at a time, first one, f is continuous on the open interval from a to b. Well, this has to be true because f prime exists on this whole interval. So if f is differentiable, because f prime exists, if f is differentiable, then f is also going to be continuous. So just to write it out here, f prime exists, therefore f is continuous, therefore yes, this has to be true. All right, next one. F is decreasing on the open interval from a to b. Well, f is going to be increasing wherever f prime is negative. And we see here that f prime is greater than 0 for part of the interval from a to b. Not the whole thing, but at least part of it. So that means there's parts of this interval where the f function is actually increasing. So that means that this is a no, this is not true. Not for the whole interval anyway. On to the next one. Graph of f is concave down on this interval. Well, f is going to be concave down wherever f prime is decreasing. F prime is decreasing for the entire interval, so this is going to be true then, which means that choices 1 and 3, options 1 and 3, are correct, so then choice C. On this one, we are given the graph of y equals h of x right here, and we want to know which of these graphs below could be the graph of h prime. Okay, so let's take a look at a few key features here. One thing I notice right away is that the graph of h has 2 extrema. That means that h prime is going to cross the x-axis twice, 2 zeros. So taking a look at our options here, A only crosses once, same thing with B. C, D, and E all cross twice, so those are okay, but we can eliminate A and B right off the bat. Another thing I notice is that h is going from increasing to decreasing to increasing. That means that h prime must be going from positive to negative to positive. So taking a look at our remaining choices here, choice C starts negative. It goes negative, positive, negative. So C definitely is out of the running. D goes positive, negative, positive, so that's okay. E is also positive, negative, positive, so it's down to D and E. Now, one other thing I do notice here is that we have a point of inflection, one point of inflection, somewhere around the y-axis here. So at least one point of inflection. So looking at D and E, now what does this point of inflection mean for the derivative? It means that we're going to have one local extreme for h prime. So taking a look at D and E, D has 1, 2, 3 local extrema. E only has the 1. So D is no good. We're going to have to go with choice E. On this free response problem, we're given this graph of f prime on the interval negative 1.2 to 3.2. We're told that f of 1 is 2, and we're also told where we're crossing the x-axis. So it basically is what it looks like. We're crossing at negative 1 and 3. We have a horizontal tangent at 2, and then there's the g function that is really just e to the f of x, which is kind of interesting. Okay, so the first part of this problem is they want an equation for the line tangent to the graph of g at x equals 1. So in general, I'm going to use the point slope formula here. Y minus y1 equals m times x minus x1. Now applying that to this problem, they want to know about the tangent line at 1. So the y value at 1 is really going to be g of 1. So this is y minus g of 1. The slope is going to be g prime of 1. and then this is going to be x minus 1 in here. Let's talk about g of 1. So g of 1 is just going to be e to the f of 1. Well, what is f of 1? They told us up here, f of 1 is 2. So this is really e squared. Next, we need to talk about g prime of 1. Let's talk about g prime of x first. To take this derivative, I'm going to need to use the chain rule. So this is going to be e to the f of x times the derivative of f of x, which is f prime. So then I'm doing g prime of 1, that's going to be e to the f of 1 times f prime of 1. Well, e to the f of 1 we just saw up here was really e squared. How about f prime of 1? Well, here's a graph of f prime, and we see that the input value of 1 gives us back an f prime value of negative 4. So that's e squared times negative 4. Okay, let's plug it all in now to this point slope formula. So we've got y minus the y value that we just found here of e squared. G prime of 1 we saw was negative 4 e squared. And then this is still going to be x minus 1. For this part of the problem, they want us to find all x values on this interval where g has a local maximum. Now, to do this, we have to figure out where g prime is changing from positive to negative. And g prime, remember, from part A was really just e to the f of x times f prime of x. So we're going to have to do a little bit of sign analysis with this. Now, what's going to make our lives a little bit easier here is that e to the f of x, since it is an exponential function, is always going to be positive. Therefore, it is only f prime of x that is going to determine the sign of g prime of x. And just looking at the graph here, we see that f prime of x, and thus g of x, changes from positive to negative at x equals negative 1 only. Therefore, this means that the g function has a local max only at x equals negative 1. On this part of the problem, they're telling us that the second derivative of g is g double prime of x equals all this craziness, which we probably could have figured out on our own, but it's nice of them to save us a little time and just write it out for us. So what they want to know is g double prime of negative 1, positive, negative, or 0. Okay, so we already know what g double prime of x looks like. Let's just plug negative 1 into all of this. So we have e to the f of negative 1 times, this is going to be f prime of negative 1 squared plus f double prime of negative 1. Negative 1 plugged into all these places. And we don't even need to figure out what this comes out to numerically. We just need to know if this whole thing is positive, negative, or 0. What could be harder, right? Or what could be easier? All right, so let's look at each piece of this. E to the f of negative 1. They didn't tell us what f of negative 1 was, but since this is an exponential term, we know that it's going to come out positive no matter what. In here, f prime of negative 1, we actually do know what that is. If you look at the graph here, f prime of negative 1 is on the x-axis, it's 0. And then f double prime of negative 1, well, that's the slope right here. Since we already know that f prime is decreasing from negative, at least negative 1.2 to 2 right here, that tells us that f double prime of negative 1 must be a negative number. So putting it all together, we have a positive times 0 plus a negative. Well, that really just means we have a positive times a negative, which means that g double prime of negative 1 must be a negative number. For this last part of the problem, they want us to find the average rate of change of g prime over the interval from 1 to 3. So this is just an AROC kind of formula. Now, recall from part A that g prime, again, was e to the f of x times f prime of x. So yes, they want you to find AROC for this thing from 1 to 3. So that's going to be, in general, we have g prime of 3 minus g prime of 1 all over 3 minus 1. And then simplifying this a little bit, well, let's just turn that denominator into a 2 right away. Upstairs, this is going to be e to the f of 3 times f prime of 3 minus e to the f of 1 times f prime of 1. And let's just go through this term by term and see what we can say about it. So e to the f of 3, we don't really know what that is because we don't know what f of 3 is. They didn't tell us anything about that. So we're just going to leave e to the f of 3 the way it is and hope for the best. But this next thing, f prime of 3, well, we can look that up in the graph. F prime of 3 is on the x-axis, so that's going to be 0. Well, that helps. So we don't even need to know what e to the f of 3 is because it's getting zeroed out anyway. Now, e to the f of 1, we know that because they told us f of 1 was 2, so that's just going to be e squared, and that's being subtracted right now. And then f prime of 1, we already looked that up in an earlier part of the problem. That's this point right here. That's negative 4. So simplifying this, which you don't have to, but we could. Yeah, we probably should, because this e to the f of 3 is still unresolved. So simplifying this then, we have positive 4e squared over 2, which is just going to be 2e squared.